So when you see these rational expressions with x in the denominator and something that looks factorable, you would try to factor this, and you would maybe even try to see if you could make it so it's the same as this one, so that it's easier to combine the fractions with common denominators. Or you can make a common denominator. So looking at this 9 minus x squared, how would we factor that, or what is that?
A difference of squares.
Yeah, this is a difference of squares. Just generally a difference of squares. If you forget, you can take a look at some older videos, but difference of squares is generally when we have something squared minus something else that's squared. So we have 3 squared minus x squared. And so we're going to factor it. If you want to do some review, look up some videos on difference of squares. So we have a difference of squares, 3 minus x times 3 plus x in the denominator. Now hold on a minute, why is that not the same as x minus 3? Here we have 3 is negative, x is positive. We don't have a negative 3 anywhere. So we actually have to change one of these. How do we change one of them?
You bring out a negative sign?
Yep. We're going to factor a negative out of the bottom. Are we allowed to just factor a negative 1 out of the bottom? Let's see. So that'll give us our negative 3 and our positive x. There it is. Here's our negative 3 and a positive x. We've just written it the other way around. They're both still there. It's the same thing. Let's check. Factor the 1 back in. So this is the distributive property. We're doing a check here to see if we've done this correctly. Like, just take a minute to do that from time to time. So in the first binomial, we'll have positive 3 minus x, distributing that negative 1 back in, just to check. And is that the same thing as what we had up here?
Yeah.
It is the same. Therefore, we can do it. So we didn't have to actually distribute the negative 1 into just the first one. We could have distributed it into just the second one. But the important thing is that you only distributed it into one of them. If we distributed it into both of them, that's incorrect. You can't do both. It's always just one of them. Sometimes an analogy is easier to understand, so I'll make an analogy. So let's say we have something simple like 3 times 4. We all know is 12. We're going to use that as our example. So I could, if I wanted to, factor a negative 1 out of the 3. I'd just have to make the 3 negative. And notice how the 4 doesn't become negative. I just want to take the negative out of one of them. Just making sure that this should always equal positive 12. If it equals negative, then we did something wrong. So I can do that. I could also take a negative out of the 4, leaving the 3 for now. If I factored a negative 1 out, this would become negative 4. And we could see that multiplying these together is positive still. So you can see that when we factor negative 1 out front, it only changes one of the signs in brackets. We're not actually doing both. Like, this would be wrong. It would be wrong to take out a negative 1 and make everything negative. You could see how we don't do that, because that's not equal to positive 12 anymore. That would be negative. So just as an analogy, hopefully that proved to you or made it make more sense. So we're going to go with that in our denominator. We did that so that we could get the same thing in blue here. And I can rearrange that in a minute.
I'll just rearrange it for people to see more clearly.
Instead of minus 3 plus x, I'm going to write this as x minus 3. And now we can see it's the same. Simplifying, I'll show you another thing with when we have a negative down here. Maybe you know that, well, the 1 is redundant. We can move that negative up here. It's the same thing. Did you guys know that? Yeah, so we're allowed to move that negative up top. So now we've got our denominators looking a little bit neater. What's next? Make a common denominator with our 3 plus x, or our x plus 3. Let's just write this as x plus 3. It's typically the way we write our binomials, with the variable first. So we need to put that on this other fraction. How do we get it so that the bottoms are the same? So we're going to multiply the top and the bottom, of this fraction that doesn't have it by our x plus 3. So we're just multiplying the top times x plus 3 and multiplying the bottom times x plus 3. And you can see that our denominator would now be the same. And on the top, we'd have 5 times x plus 5 times 3. So let's write that and simplify a bit further. So we've made our common denominator. Now is where we can combine our fractions. So we have our -2 from the first fraction and our 5 times x plus 3. So I'll just write that out showing my work. Right? And then I'll use the distributive property and I can combine the terms on the top. So on the top we'll have 5x plus 15 minus 2 will give me plus 13 all over the same stuff in the denominator. We're not quite done yet. We still haven't stated the restrictions, which are, remember, any value of x that would make the denominator equal to 0 or undefined. You can see from here that x cannot equal, the solution for x there would be positive 3. So x cannot equal positive 3, otherwise the denominator would be 0 and it would be undefined. And x cannot equal -3, because that would also make the denominator equal to 0. We do a quick check to see if there's ever anything else for x that would make the denominator 0. And it looks like we've taken care of everything with a positive 3 and a -3. So these are our only two restrictions.